Hi, this is Mike Tierney of Data Not Distress, and in this video I'd like to answer the question, so many people say COVID-19 is one virus. What do you mean by the deadliness changing? In 1859, a scientist by the name of Charles Darwin wrote a book on the origin of species, which outlined his theory of evolution, the idea that living things change slightly over time by each being a little bit different from their parents. Those differences would then play out through a system of competition where individuals better able to survive than others will live longer to then be able to create children who will carry on some of those traits. The theory was very controversial because it speaks to humans as just another animal species that evolved from others rather than being something magical or otherwise special. The preferred view at the time was of creationism, the idea that God had magically created humans and all other animals so they couldn't ever change. Over the next 160 years, human science came to accept Darwin's theory of evolution as a much better way of describing and understanding the natural world, a theory that we can actually see play out in our everyday lives. Bacteria and viruses are perfect examples of organisms that we can observe regularly evolving because they have much shorter lifespans than ours. The emergence of antibiotic-resistant strains of bacteria that previously had been susceptible to the antibiotic is an indicator of bacteria evolving over time. The antibiotic became a hurdle around which certain bacteria survived, and only those survivors get to reproduce others who then share their same traits of resistance. Viruses are even smaller than bacteria and so are even more difficult to observe directly. But you can see evidence of viral evolution in their behavior. For example, in the pattern of our cold and flu season deadliness every year as seen here. Viruses do not have calendars. They do not even have enough biological processing to begin to understand what a calendar is. And yet in the United States, cold and flu season deadliness peaks like a finger coming up in December, pointing at January, and then just as quickly dissipating into February and March, just about every single year. We know that the cold and flu doesn't just disappear every year. People are still getting it through the spring. But somehow, the people who get it later in the season have less and less trouble with it, like it has become a different virus. The reality is, it has become a different virus, or more specifically, a different set of strains of virus. But why that seasonal pattern? Viruses don't have calendars, so how are they timing this? The likely answer is our behavior of cold weather lockdowns every year. In December, coming into winter throughout the continental United States, it gets cold enough to feel the need to stay indoors, with the windows shut and not go out as regularly as the rest of the year. What this means is that any viruses people encounter end up being reproduced by them, collecting inside their homes where they are then breathed back in by the same people, leading to an infection by a predominantly single strain of virus. Any given strain of virus will have a certain set of behaviors when interacting with the cells of a given host. If you get enough of that one strain, whatever behaviors it is programmed with, such as those that lead to pneumonia and deaths, will then be exaggerated because all the virus particles are so similar. What happens in the spring is that we start going back out again. As soon as it is warm enough, we open windows to air out, lowering virus concentrations. As we start going out in public and interacting with others more, what happens is we start to encounter strains of the same virus that have been reproducing in different hosts. Viruses reproduce by using the cells of each specific host, and each host has different DNA and thus different proteins for the viruses to use in reproducing themselves. And so different types of mutations occur in different people, just because of the chemical differences between us. Those new viruses that could never have been created by one person then end up passing to others to continue the chain of evolution. What that exposure to an array of different strains of virus does is keep any one strain from being the predominant strain. The behaviors that any one of them might have are tempered by the presence of other strains, and all of a sudden a new dynamic opens up in the virus world: competition. Whereas a wintertime virus gets to reproduce without worrying about other viruses getting in the way and taking up cells that any one of them could have used, a springtime virus needs to compete for those cells. It begins a dynamic of the viruses fighting amongst themselves for hosts. And in that environment, the virus that causes the least illness will lead to the healthiest hosts, who are then able to reproduce the virus most widely. As that less deadly virus spreads, even more people begin to develop antibodies that work against any of the season's virus strains that they have encountered in their saliva, mucus, and blood. Those antibodies are like a lock and key, looking for specific parts of a virus to bind to and thus kill. With enough people with those antibodies around, together they act almost like a vacuum cleaner for the air, bringing in virus particles which then land in their saliva or mucus, where they then bind to those antibodies and die, gone forever. This leads to fewer people even so much as encountering the virus, on top of essentially smothering any given deadly virus in less deadly mutations of itself. The result then is the plummeting in deadliness, which we see right on that chart every single year. Every year we neuter deadly viruses by spreading it amongst ourselves, often called herd immunity. Herd immunity isn't just about us, nor just about immunity. It is about changing the virus in the only way it can be changed, by causing mutations of it across a population of hosts, with each of us sharing our part of the solution to airborne disease. Together, we change airborne illnesses to make them less deadly.